Thank you. I'm called Junior Nkuranga. I have a topic called a simulation-based risk interdependence network model for project risk assessment. In introduction, project risks are mostly considered to be independent in risk management, ignoring interdependencies among them, which can lead to inappropriate risk assessment and reduced efficacy in risk treatment. So this study will introduce a new Monte Carlo simulation-based risk interdependence network model to support decision makers in assessing project risks and planning risk treatment actions more effectively. Project risks is managed to reduce the project impact towards the project objectives as the project usually is exposed to the risk. That's why it's very paramount and effective way to mitigate the risks. So, project risk assessment is comprised of main phases, including risk identification. And this is the process of documenting any risks that could keep an organization from reaching its objective. The next one is risk analysis, which is the process of identifying and analyzing uh, potential issues that could negatively impact key business initiatives or projects. The third one is risk response planning, which is the process of developing options and determining actions that could enhance opportunities and reduce threats to the project. It includes the identification and assignment of individuals or parties to take responsibility for each agreed risk response. And the fourth phase is risk monitoring and control, which is the process of keeping track of the identified risks, monitoring residual risks, and identifying new risks, ensuring the execution of risk plans, and evaluating their effectiveness in reducing risk. Furthermore, risk interdependence, interpretive structure modeling, Monte Carlo simulation, and sensitivity analysis are the methods and models used to assess and monitor the project risk. So, in evaluating parameters of the project RIM, this is the development of an Monte Carlo simulation-based RIM model, the two concepts from classical probability and impact model. PI means probability and impact risk model, as it is shown in the two diagrams. There are different sophisticated PRA methods used to represent model risks interdependencies. The first one is failure modes and effective analysis, which is abbreviated as FMAIR, which is the systematic approach for determining the various model of the failure. The second one is fault tree analysis, uh, which was developed like to construct failure through logicals and O. So the third one is Bayesian belief network, which is abbreviated as BBN. It is a probabilistic model which given in directed cyclic graphs that represent network structure, and it is correlated with the conditional probability. The next one is design structure and matrix, which is abbreviated as DSM. These are the principles under analytical hierarchy process, the fifth one. These are the principles which are used to construct a risk numerical matrix by examining their causes and consequences for catching the risks interaction. So this method of incorporating the complex interdependencies has expanded due to more developed of the other methods of identifying risks. They are no longer commonly used. The next one is structural equation modeling, which are statistical methods to reorganize complex interrelations among The same can't be applied to check out the probability of occurrence unless it is applied to interdependencies among risks categories. The next one is social network analysis, which is abbreviated as SNA, which is rated with analyzing structure and systems pattern components and is used to detect the risk cause effects on individual risk. So the last one is interpretive structure modeling, abbreviated as ISM, is the purpose of determining the interrelationship of system elements and it identifies all by transitive interfere. In addition to the ISM has been used in recent years in the risk interdependencies. There is another one. Some Monte Carlo simulation-based PRA methods is widely used as it is helpful the decision making to solve the problem of the uncertainty. It has the ability of measuring the stochastic behavior risk and generate the statistics of outputs under uncertainty, which makes the MCS as a promoting technique among PRA methods and is associated in terms of probability and impact. So this is the framework of the proposed decision support system for PRA. It has three parts. It has identification, assessment, and this one, which is treatment. It looks a bit not clear. So it has inputs and outputs. So there are different limitations of PRA, and the first one is its inability to tackle the complexity risk evaluation, which means it's not able to tackle more complex risks. It's insufficient in modeling stochastic behavior of project risk occurrence. Again, Monte Carlo simulation alone fails to explicitly model complex risk interdependencies. Additionally, existing PRA methods usually stop at the risk evaluation phase, with a little attention given to planning and evaluating risk treatment actions. In conclusion, to perform better risk treatment, we should take into account the interdependencies among project risks. And this study has explored an intelligent simulation-based decision support for assessing project risks and facilitating risk treatment in the context of risk interdependencies, which makes it both academic and practically contributions to the field of project risk management. Thank you so much for your attention.